Imagine a world where machines can understand and respond to human language with exceptional accuracy. It's not a distant science fiction dream, but a reality we are living in thanks to the evolution of language models. But what exactly brought us to this point? Let's take a trip back in time. Language models in their simplest form were born from the idea that we could teach machines how to understand text, much like how we humans do. These early models were rather rudimentary, relying on simple algorithms that could only predict the next word in a sentence based on what came before it. They were like children learning to speak their first words with a limited understanding of context or nuance. Fast forward a few years, and we saw the rise of more advanced models, ones that could not only understand text but also generate it. These models were trained on vast amounts of data, learning from billions of sentences to understand the intricate rules and patterns of language. Then came the era of transformer-based models, a game changer in the field of artificial intelligence. These models took language understanding to a whole new level, capable of processing text in parallel and understanding the context of a sentence. Not just the words in it. They became the building blocks for applications we now take for granted. Virtual assistants that can answer our questions, chatbots that can help us shop online, and even software that can write content as well as a human. But the journey doesn't end there. The language models of today are getting smarter, faster, and more efficient. They're not just understanding language, they're reasoning, predicting, and even correcting human errors. They've become an essential tool in our digital world, bridging the gap between humans and machines. Now let's dive into one of the latest and most impressive language models to date, Phi-2. Microsoft recently unveiled a language model that's shaking up the AI world, Phi-2. In the vast universe of artificial intelligence, Phi-2 has emerged as a new star, boasting a mind-boggling 2.7 billion parameters. Yes, you heard it right, 2.7 billion. This is not just a number, but a testament to the immense complexity and potential of Phi-2. Diving deeper into its structure, Phi-2 is a transformer-based model. For those of you not familiar with the term, transformer models are a type of deep learning model that use self-attention mechanisms to understand the context and meaning of words in a sentence. They have revolutionized the field of natural language processing, and Phi-2 is the latest addition to this exciting family. But the uniqueness of Phi-2 doesn't end with its structure. This model has been trained on a staggering 1.4 trillion tokens. To put this into perspective, that's like reading every book in the world's largest library, not once, not twice, but thousands of times over. This extensive training allows Phi-2 to understand and generate human-like text with an uncanny level of accuracy. However, Microsoft didn't just aim for accuracy with Phi-2. A significant intention behind this model was to focus on safety and reduce toxicity and bias. In an era where AI ethics is a hot topic, Microsoft is paving the way by creating models that not only understand language, but also promote a safer, fairer digital environment. But what makes Phi-2 so special? Let's take a closer look. Scene script. Phi-2 demonstrates exceptional reasoning and language understanding capabilities. If you're wondering what makes Phi-2 stand out, let's dive into its impressive capabilities. It's like a well-rounded scholar with a vast amount of knowledge at its disposal. It's not just about understanding language, but also about applying that understanding to solve complex tasks. One of the most fascinating aspects of Phi-2 is its ability to solve physics problems. Yes, you heard it right, physics. It's not about just crunching numbers or following formulas, it's about understanding the principles and concepts behind those equations and applying them to solve problems. Imagine having a personal physics tutor that never gets tired and is always ready to help. That's Phi-2 for you, but the capabilities of Phi-2 don't end there. It also excels at correcting student mistakes. Now, we all know learning is a process, and mistakes are a part of that process. But what if you had a tool that could not only identify your mistakes, but also explain why they are mistakes and how to correct them? That's exactly what Phi-2 does. It's like having a patient teacher who guides you through your learning journey, helping you improve and grow. These capabilities make Phi-2 a versatile tool. It can be used in education to support students in their learning process. It can be a valuable tool for researchers, providing insights and solutions to complex problems. And let's not forget its potential in the realm of language understanding, opening up new possibilities in natural language processing and machine learning. But versatility is not the only thing that makes Phi-2 special. It's also about efficiency. Phi-2 is a transformer-based model trained on 1.4 trillion tokens. Despite its size, it outperforms larger models, showcasing the power of optimization and smart design. And while Phi-2 is a technological marvel, it also focuses on maintaining safety and reducing toxicity and bias, making it a responsible and ethical AI tool. But how does Phi-2 match up against other models? Let's find out. When pitted against larger models, Phi-2 doesn't just hold its own, it outperforms them. This is no small feat. Let's delve into how Phi-2 measures up to its competitors, particularly Google's Gemini Nano 2. Gemini Nano 2 is a formidable contender in the world of artificial intelligence. It's a model that has been applauded for its superior performance and capabilities. Yet when up against Phi-2, we see a fascinating scenario unfold. Despite being a smaller base model, Phi-2 matches, and in some cases even surpasses, the performance of the Gemini Nano 2. This isn't just about who wins in a head-to-head contest, it's about redefining what is possible for smaller base language models. Phi-2's performance is a testament to Microsoft's focus on maximizing efficiency and effectiveness rather than just blindly increasing the size of the model. The company aimed at pushing the boundaries of what smaller base language models can achieve, and with Phi-2 they've done just that. In the world of AI, bigger isn't always better. Phi-2's ability to outperform larger models is a clear illustration of this. It's not about the size of the model, but the power of its functionality and design. Furthermore, Phi-2's versatility is truly noteworthy. Its ability to solve physics problems and correct student mistakes, for instance, is not something we usually see in language models. This just goes to show that Phi-2 is not just about language understanding, it's about reasoning and problem solving too. So, what have we learned from this exploration of Phi-2? Well, we've seen that smaller models can indeed hold their own against larger ones. We've seen that Microsoft's focus on efficiency and effectiveness has paid off. And most importantly, we've seen a glimpse into the future of AI, where size is not the only measure of greatness. Today we've taken a deep dive into Microsoft's Phi-2, a language model that's setting new standards in the AI world. We've journeyed through the evolution of language models, witnessing how they've grown in complexity and capability. We've unveiled Phi-2, a model with a staggering 2.7 billion parameters, trained on an astounding 1.4 trillion tokens. We've explored its impressive capabilities, from solving complex physics problems to correcting student mistakes. And we've seen how it stands up against other models, matching or surpassing even Google's Gemini Nano 2. In essence, Phi-2 showcases the incredible strides Microsoft is making in pushing the boundaries of what smaller base language models can achieve. If you enjoyed the video, please subscribe to our channel and don't forget to like and share. Stay tuned for more insightful content on AI and technology.